Shaun. Morning, everyone. So, yeah, I have the enviable task of looking after the problem that everyone's just talked about, where we have to try and figure out what do the skills look like for the next generation? How do we make sure that we're bringing through the next generation of talent? So I am the early careers lead for engineering at Kainos, and for probably the last couple of years, probably since ChatGPT came out, I have had hundreds of conversations of people coming to me saying, how do we get more AI in our early careers training? And for years, my answer never really changed. I didn't think the technology at that point was mature enough that we could do that switch without it having an impact on our talent pipeline. When we had this conversation at the start of 2025, that narrative had kind of changed at that point. Our teams had started making use of tools like GitHub Copilot, and the way that they worked and the way that we were seeing our teams being built and operating was changing very quickly. And so our training had to change and adopt to make use of that. So this is a story of how we completely changed our training academy and the lessons that we learned from that. I'm hoping that there's probably a lot of organizations in the room at the minute that are going to be going on the same journey very soon. So maybe you'll be able to take some lessons from this. So this wasn't originally part of my slides. As an industry, I think we're absolutely obsessed at the minute with talking about LLMs, and models, and agents, and agentic AI. And I think it's very easy to forget about really the core of how we've always solved problems, and that's the people problem. So for me, whenever we're hearing about all of these problems that we're going to have to solve, we actually don't really know what problems we're going to have to solve in the future. The people that are going to be solving those are the problem solvers, the critical thinkers, the people who you can give a challenge to, and they'll run with it. So I love this. This is an article. You'd be forgiven for thinking Kainos hiring 60 people is not normal, or it's just normal. This is from nearly 30 years ago, and there's a quote there that says, our policy is to select the best graduates we can find from whatever the source. And Dave mentioned it, and I think there's going to be a lot of people mention it today. A lot of the industry is talking about pulling back on hiring junior talent and training that and building that pipeline. But I'm actually thinking the other way. I think we need to bring more people in who are AI first, who are built from the ground up, and let them solve the problems of the future. So the first real big change that we saw whenever we started embracing AI was around how our teams operate. For us, what we see happening is that the lines between the roles are starting to blur a little bit, where with an AI agent, a dev can build a feature, they can write the playwright test to test that feature, do a bit of QA, they can write the GitHub Actions workflow to build and deploy it, they can write the Terraform code. So really what we're talking about is how do we make sure that the next generation has these skills in mind if that's how we see our teams moving. This led us towards more of a T-shaped approach. So I know Rachel, who's on one of the panels later on, gave a great talk at AICon last year about this. It's still available on YouTube, so if anyone's interested, I'd recommend going and taking a look at that. So rather than me just standing here talking about this as a change, I thought what would be really interesting is if we brought one of our recent apprentices to show you guys what they did as part of their recent academy. So if everyone would welcome Anna to the stage.
Hi, I'm Anna. I'm 20 years old and I just joined Kainos this year. Before I was at Kainos, I went to Ganley Collegiate where I did digital technology. I didn't have much of a coding background back then, so I'm going to go through what we did in those 16 weeks and how it's kind of brought me up to speed both technically and professionally. So our journey began with the focus on software engineering, but our first 2 weeks were dedicated to pure exploration. We were given the freedom to experiment with AI without a rigid structure, simply to see what it could actually do. We built tools like egg timers and random team generators, which may seem basic, but they were vital. They helped me understand the power and the limitations of AI, and more importantly, They built my confidence to solve problems independently and think creatively, skills that are essential in any modern workplace. So I've put together a short demo to show you guys what we did during the academy. Perfect. So by week 3, we moved into structured development. We built our own job application platforms. This is when the work became real. We operated in agile sprints, and we utilized parallel development and version control to collaborate effectively as a team. Daily communication, shared problem solving, and clear ownership of tasks were essential when keeping our progress aligned. One of our key sayings during this phase was to fail fast, identifying issues early, to learn from them quickly, and iterate with improvements rather than waiting until the end to fix problems. We implemented everything from secure login systems and CRUD functionality to integrated AI chatbots. This phase wasn't just about the code, it was about professional process and teamwork. It gave me a clear understanding of what it looks like to contribute in a secure, scalable, and real-world software project. In weeks 7 and 8, our focus shifted toward testing and the end user. We progressed from manual testing to building automated pipelines that monitored our results in real time, making quality a continuous, team-wide responsibility rather than a final step. We also prioritized inclusivity using tools like Lighthouse and Wave to conduct accessibility audits, working together to review, refine, and challenge each other's work, sharpened my attention to detail, and reinforced a core principle. High-quality software must be user-focused and accessible to everyone by design. Next, we did platform engineering, where we brought our applications to life in the cloud. We deployed our work using Azure and Terraform and managed containerization through Docker, navigating the challenges of private endpoints and managed identities. This required patience, collaboration, and a structured approach to problem solving. By keeping our infrastructure simple and intentional, it ensured our solutions were scalable and secure. This was a turning point that helped me understand exactly how application moves from local development environment to a live production-ready system. Finally, we concluded the journey by exploring data and low-code development. Using Databricks, we analyzed a data set of over 12 million taxi records, identifying patterns and training AI models to generate predictive insights. Collaborating on a scale of data strengthened both analytical thinking and my ability to communicate technical findings clearly and within a team. We used Power Apps and Copilot Studio to rapidly translate data insights into functional applications, proving how AI-powered low-code tools can drastically accelerate the delivery of custom business solutions while still maintaining clarity and simplicity in design. Ultimately, these 16 weeks have been more than just a technical toolkit. This experience has strengthened my ability to master new systems at speed, and more importantly, how to solve complex problems within a team. I'm walking away with more than just confidence to collaborate effectively, embrace challenges, and with the fail-fast mindset, build simple and scalable solutions, and add immediate value to any professional environment. Thank you so much.
That's a bit nuts, right? That's a lot in a very short space of time. This is going to terrify a lot of people because it terrified me whenever we started thinking about this last year. We put AI in the hands of our junior developers from day one, right? Anyone here who started out their career as a dev, that idea is terrifying, and it still terrifies me a little bit to this day. So what we needed to do was to think about how we work backwards from giving access to the tooling to make sure that they get the skills out of the training that we needed them to be able to get. So in Kainos, we've historically always focused on the basics. So it's building up from knowing syntax, writing a line of code, writing a method, writing classes. So what we wanted to focus on was how do we make sure that we're still getting the patterns and the use out of the AI agents to make sure that they were getting the skills that they needed. And this really comes down to the fundamentals. So when we think about the traditional approach for training junior engineers on projects, and I'm sure if any of you guys can relate to this and you have junior people or when you were starting your careers, we always think about small changes, right? They all start with bug fixes, 1-2 line changes for probably the first couple of months. With AI agents, you no longer need to have that restriction in place. We now have the ability to give people the ability to make bigger changes, to change features or epics, much broader spectrum than they previously had access to. I think what we're all seeing right now is AI magnifies your coding practices, and that's both in a good way and a bad way, right? If you have your structure and your fundamentals set up on your projects, if you have your CI/CD pipelines, your automated tests, things to validate the output of what you're doing, AI is probably going to accelerate how quickly you can build. But in the inverse, if you don't have those guidelines in place, you're very quickly going to get yourself into a mess of just thousands of PRs and thousands of lines of code changes without really being able to get the benefit of delivering any quicker. So whenever we're focusing on this, we're looking at, and I think it comes back to a lot of the things that Dave talked about, is building in those design principles, the system design, the quality. It's pulling the junior developers away from the baseline of just writing code to thinking about how do you build a system in a way that makes sure that these engineering fundamentals are at the heart of it. So one of the big things that we did was to focus on, and again, this has been mentioned before, spec-driven development. So rather than giving someone a problem and letting them just get into the code and start writing code to try and fix the problem, what we really wanted to focus on was taking a problem specification and making sure that we're getting quality output from that. I'm sure everyone in this room remembers the first time they used ChatGPT to generate any code. It was crap, right? It took you 3 or 4 minutes to generate a bit of code and probably the rest of the week to try and make it work with the rest of your code. That changed whenever agentic AI and coding agents started coming in. But I think what that shows is that the quality of your output is completely tied to the quality of your input. So whenever you're thinking about new problems, solving problems, features, whatever level that might be, you need to be thinking about what goal do you want to achieve, what constraints do you want to put in place, give it a bit of context. So what frameworks do you use, what libraries do you use? If you give AI the option, it's just going to go off and start importing everything, new things to fix the same problems as tools you'll already have, and the acceptance criteria as well. So we've been using SpecKit as part of our training. I'm sure there's other tools out there and other ways to solve the same problem. A big change came from the day-to-day training of how we focus and how we let our junior engineers work. Previously, we had always given them a set of steps for getting towards an outcome. So it's write this line, write this method, do this thing, and this will happen. What we realize is that that's not encouraging critical thinking and problem solving. So we moved away from that this year to focus more on outcome-driven an outcome-driven training approach, where we would give people an end goal and ask them to work with their teams, work with AI to get to that. And what that will do is that will mean everyone within that team has a different way of solving a problem. Every team comes to a different approach. Whenever you're doing this on a project, obviously that approach would be validated by someone more senior. But the goal is to get from the problem to the feature rather than telling them how to do that. One of the unforeseen consequences of Anna's Academy was that our senior devs who were mentoring at the time had 500 PRs in the space of 6 weeks. That's not sustainable, right? We don't want to get into a point where all our senior devs are doing is reviewing AI-generated code, right? Because that's not the best use of their time. So we came up with a bit of a process. So the first thing you had to do was review your own pull request, right? That seems like quite an obvious thing that you would want to do. You wouldn't believe the amount of times that people have things in pull requests that shouldn't be in there. And if they just sanity check their own, they would realize that okay, I need to remove that before I send it to anyone. The next step was then getting code review from an AI. So we were using GitHub. So we use GitHub Copilot code reviews. Anyone that's used these knows that out of the box, it's actually pretty crap. But what you can do is you can configure it through your instructions files to tell it the things that you want to look out for, the patterns that you want your code to be following. And that means that what you get back from it are actual useful code review comments that you can then implement. The next thing was to get a review from another junior on your team. So this was actually a bit of a twofold. It was good for the reviewer to be reviewing someone else's pull request, because then they can see how other people are solving problems. But they're also then able to learn from how they've solved that. They're able to learn from the feedback that then comes out of that, because the next step is then to get the senior engineer to look at this. And at the start, what that meant was you're probably getting 40 comments still from a senior engineer by the time it got to the end of that. But by the end of it, what we were seeing is the number of comments in every pull request was significantly going down. But that's a big investment up front to get to that point, so just be aware of that. Mob learning. What we used to do in our old academy was we would spend the first 4 days of a week introducing a new concept. So we'd do databases, APIs, web dev, and then towards the end of the week, we would do a group project where you bring everyone together, give them a problem statement, and let them work towards it. What we saw was actually those days were the days where people were getting the most out of the training. So we completely flipped how we do the training now, where at the very start of the academy, you're put into a team of two, 3, 4 people, and you start to think as a team to try and solve problems. So you're getting different perspectives, different outcomes, coming up with different ways of thinking and getting to the end of it. And that's actually worked really well, rather than just training individually. And the last thing, this was not part of the original agenda, no AI days. So what I thought was going to happen was we were going to give people access to AI, they were going to love it, use it, that was going to be the end of it. But actually the feedback that we got from the group was they would like to get the experience of building without AI. So every week what we did was we turned the AI off for the day and see how things went. And what we found was that it was forcing people to start getting better at understanding the output, but also debugging through any problems that they have, because previously if something hadn't worked, you would just go back to Copilot and say, hey, this isn't working the way it's supposed to, can you fix it? But now you had to be the person to go through and fix what the AI had generated. What we found was that actually whenever we turned the AI back on the following day, we were getting a lot more value out of the output. You were able to understand it a lot more. And I highly recommend that for anyone who's thinking about this. The last thing about is what's next. So when agents, and we've already touched on this, and I'm sure it's going to be touched on through a lot of today, when the agents are able to generate the features, refactor the systems that operate across multiple layers, the one most valuable skill is no longer typing the code, it's understanding the system that the code lives in. So we're seeing junior engineers very quickly move into what are architect behaviors. I'm sure a lot of architects in the room are getting their backs up right now saying, oh no, my job's going. I'm not saying that these guys are going to be architects. What I'm saying is that these guys are going to have much more architectural thinking and considerations into how they're building things, and the job of an architect will still exist, so it's okay. So they're thinking about the boundaries and the reasoning and the data flows and deciding where the agent should actually operate and where it shouldn't. So orchestration is going to become a really big skill, knowing how to break down the work and set the constraints and how to guide the agent through a system safely and how to review the output. So it's not just does it work. So architecture it's not a title that you earn after 10 years. It's a way of thinking because AI is doing the execution. Humans are responsible for the shape of the system, the risks it introduces, and the outcomes it produces. It produces. So what's next? We see teams being made up of fewer engineers who are working across multiple different disciplines and thinking much more about the system and the architecture and how everything connects and works together, how changes impact upstream and downstream dependencies, things that you wouldn't really have considered when you were a junior engineer before. So that's the end of my talk. I am going to be around all day if anyone has any questions. So thank you very much for listening, and I hope you maybe have some value out of this that you can take back to your own organizations. Thank you.